All right, we're going to get started here. If you have questions, please go ahead and leave those for the end. The reason being, I'm going to come around and give you a microphone so you can go ahead and ask those. So we'll take those questions at the end. And with that, I'm excited about this. We were just talking about getting observability into your apps, and it's something you really need to make a lot of those decisions. And I don't think there's anyone better to answer that question here than Jonatan. So I'm excited about that. And with that, you take it away, sir.
Thank you. So welcome, everyone. This is the first observability talk on this conference. There will be another one. This is covering more like the basics, and there will be an advanced one on Wednesday. So please make sure, if you like it, just like come and tell to your friends. If you absolutely hate it, tell your enemies. I don't care, that's fine. So I'm Jonatan. I am a member of the Spring engineering team. I work mostly on Micrometer, but sometimes on Spring Cloud and Spring Boot as well. And I work in a team called the Spring Observability team with two of my colleagues, Marcin and Tommy, who were not able to hear today. And I'm also one of the leaders of the Seattle Java user group, and you can find me online and in the Seattle area too. So let's talk a little bit about observability, and let's talk about the basics. What is it, basically? Because this is a rather important question. For this talk, we will define observability as something that how we can understand the internals of a system, which is usually software, your application, based on the outputs that it provides. And that means that basically your software will provide you some meaningful outputs. You look at that and get some insights, hopefully. But all of this is just a fancy way of saying observability is basically data about your application. And that's it. But why do we need it? And the one-word answer to this is because of complexity, because today's systems are insanely complex. We live in the cloud era. We have these like Dexter architectures or big ball of muds. If you haven't heard about those, just look at the pictures. This is Amazon, Twitter, and Netflix, or Amazon, Netflix, and Twitter 10 plus, 15 plus years ago. We have some people here from Netflix, they can verify it. So and this is kind of like this is a part of this talk when we are taking a little bit of a dark direction. I'm from Eastern Europe, sorry. So if you need to troubleshoot something in this environment, good luck. I don't want to be that guy. Also, because of the law of big numbers, on this scale, like something is always broken. And these environments are also like very, very chaotic. That means that you turn a knob here a little and applications are going down in another region. Somebody runs a bash script in S3 and your Roomba will not work. But that happened actually, like that's like a real thing. Also, we need to deal with unknown unknowns. We cannot know everything. There will be things in your production environments that you don't even know that they exist, and they can bring production down. Also, things can perceive differently by different observers, which means that maybe 100% is fine from your perspective, but at the very same time, everything is broken for your users. And that was the dark part. Let's answer one more question. Why do we need observability from the business perspective? And the one-word answer to that is because of money, I guess. So if you have like a mature observability, you might be able to reduce revenue or loss of revenue from production incidents, which means that hopefully if you are able to troubleshoot these issues faster, you can resolve them faster. Also, you will require like less specialized knowledge. You will not need a tribal knowledge and a separate tool for every single application that you have in production. You might be able just to use like one tool or three, but a low amount of them, and everyone should be able to troubleshooting things in prod without spending 10 years building that software. And also you can quantify user experience, which means that you can actually like measure what your users are experiencing in prod without guessing. So that's a great thing. And let's jump onto these three things. This is also called the 3 pillars of observability. I don't really like that because it kind of, like this term, because it kind of suggests that this is what observability, like logging metrics and distributed tracing. But I want to emphasize you that it is not. Observability is much, much, much broader than this. These are the three most important signals, and we are going to talk about this because they are the most famous. But the observability umbrella is much, much wider than this. If you are curious what else is included, like just talk after this this session, and I can tell you. So let's talk about these one by one. And I also have some examples. So logging, it is usually trying to answer the question, what happened in your application? Sometimes also able to answer why something happened, but not all the time. And it is doing it by emitting events. And these events usually are human readable, not always. So you can, for example, like grab them, but don't do that in production, please. And metrics, on the other hand, can answer the question, what is the context of these events? And it is doing it by aggregating a bunch of data. And you can like get statistics out of these. And distributed tracing, the third one, it can answer the question why that thing happened in your application by recording these events with causal ordering. So in the distributed tracing terminology, these events, or every event that can like happen in your application and you want to observe it, that is called a span. And a span is just it, it's an event. And if one event or one span triggers another one, they have this parent-child relationship. So you can basically like build a whole like tree of spans about all of these events that are interconnected together, and that is called a trace. That's why it is called like distributed tracing. It is tracing because what I just mentioned, and it is distributed because this can happen like all around your apps. And you can have distributed systems. So I have two examples for this. One of them is through a latency issue, and the other one is through an error. So let's say that you can see in your Tomcat access logs that, hey, processing of this very, very request took like 140 milliseconds. Is that good or bad? We have no idea. There could be people on this conference who are saying like, hey, I would be extremely happy if any of my application would return anything in 140 milliseconds. And there are people here who are saying that, what are you talking about? 140 milliseconds, it's not even on the table. I am in the microseconds range. 140 milliseconds, it's not even in the universe. That means that my application is completely dead. Like it's not working. So metrics can give you this context. It can say that, hey, the maximum latency in the time window was 150 milliseconds and the P59 was like 140. Within that context, 140 milliseconds is rather bad. It's pretty bad. It is very close to the max. But we don't know why. Why was it like 140? Why it is out of trend? So distributed tracing can answer that question. And it can say that, hey, your application called another one, that other one application called a database, and the database was slow. 90% of the time was spent on the database query. And it sometimes, in some cases, it can also tell you that, hey, the database was slow because you requested a lot of data. Somebody forgot to implement pagination or whatever. The other example is an error scenario. So let's say that you can see an error message in your logs. Hey, processing of this request failed. And here is your stack trace. Is it good or bad? Well, it's not good because something failed. But what is the blast radius? Is it like everything that is failing or just one-off? Like we don't know, we don't have that context. Metrics can give that to you. It can, for example, say that, hey, the error rate in this time window was 0.001 errors per second. And there were only 2 errors in the last 30 minutes. In that context, this is not very bad, but we don't know why is this failing. And distributed tracing can answer that question and say, hey, your application called another one, that other one called the database failed, and the whole thing cascaded up. And that's why you are saying that error message. And sometimes it can also say that, hey, the database call failed because there was an invalid input, because somebody forgot to validate things on the back end, maybe on the front end as well, but the database did that validation, so that's why you are saying that error. So with this, let me give you a little demo which demonstrate these concepts, and let's like walk through these signals. And the demo is like completely open source. It's on GitHub. That is the URL. The QR code should take you to the same like repository on GitHub. So this is the architecture of this demo application. It's very, very simple. The user calls a service called T-service, and T-service called T-leaf and water services over HTTP, and they have their own databases. That's it. It's definitely not the Netflix architecture that we had a few slides ago. This is kind of like this tech stack. I am using like Spring MVC, that's the first one, Spring Boot Starter Web. For the persistence layer, that's Spring Boot, like that's Spring Data JPA, which means Hibernate at the end with MySQL. For HTTP client, I am using OpenFeign. There is also like Spring Boot Actuator for observability, which brings in micrometer observation, which I will talk about that later on this talk, but on Wednesday, you will hear a lot more about it. And also the metrics backend is Prometheus. And for distributed tracing, I am using Brave as a tracing library and Zipkin as the format. And also there is this thing, data source micrometer Spring Boot, which is a library written by one of our friends, Tadaya, to instrument JDBC things. This is a pretty awesome library, and Tadaya is awesome too. Follow him on Twitter. So let's make some tea and let's demo this application. So we have this award-winning UI. And maybe you can tell I'm not a front-end engineer. I'm a back-end engineer. But last year, this time on SpringOne, we also demoed this very UI. And since then, with two of my colleagues, Tommy and Marcin, we worked day and night to improve this. And that huge improvement that we did on this UI, that's the Spring logo up there. We just added this. So it is updated. What it can do, it is basically if you you can choose a type of tea leaf and amount of water. And if you press the button, it will give you the recipe, how to make this tea. So you can choose whatever you want, for example, English breakfast. And I'm not sure I will like this flavor of tea. Internal server error, that's not good. What happened? Well, it failed. It is not much information that I am getting on the UI. Is it a one-off? Is everything broken? We don't know. Why it is happening? We don't know. Let's try to find out. And while we are like going through this, let me also demo a couple of concepts that you can get with like auto instrumentation happening in the Spring portfolio and all of the tools that are used with Micrometer. By the way, everything I will demo today is like the Spring portfolio, everything is instrumented using Micrometer. So the instrumentation is coming from there. Also, all of the products, open source products I will demo, namely like Grafana, Tempo, Loki, and Prometheus, you can use any of your tools. It should work with one exception. That's exemplars. I will talk about that. You will need a metrics backend that supports that has that feature. Prometheus has one. If you have a backend that doesn't support it, you will not be able to do it. But more and more backends like add that support for metrics. So yeah, Prometheus can do it. There are paid tools as well that can also. But as far as I know, only Prometheus is the only open source tool that has that support. But we will talk about that. So first, let's look into maybe the logs, because I believe that's what most of the people has, and that's what you usually look into. So what I did, I just like set level to error, and let me just run a query, and let's see if I can see some errors. I can. So this is saying that there was a tleaf client call, not found, 404. 404 is not internal server error. That's not found. What is happening? Like something is not good. So yeah, I can see in the logs like what happened. I still don't know. Like, is it like a one-off? Probably not, because I can see a bunch of them. I don't know the error rate right now. But let's look into this. Let's try to find out like why is this happening. And in order to do that, let's jump from any of these log statements or the log events to distributed tracing. And we are going to this jump using a thing called trace ID. So as I mentioned, there are spans, which are like the individual events. They are connected together. That's a trace. Every single span has an ID, and every single trace has an ID as well. And with a feature called log correlation, and you get it out of the box if you are using Spring Boot, you can see those IDs right here. The first one is the trace ID, and this other one, like separated by a hyphen, is the span ID. So what I can do, I can copy this trace ID, go to my distributed tracing backend, paste it, search it, and that's it. So I can do that, but I teach like Loki how to grab this ID from the logs. So I can just press this button and it will do it for me. And this is the distributed tracing like tool called Tempo. And what you can see here is basically two things. On the left, that is your call stack, what happened during this call. And on the right, you can see a timeline. The timeline is pretty useful for like latency issues. And also it's pretty useful if you want to check that what happened here is T-service called voter service. And T-service also called T-leaf service on HTTP. And you can tell from the timeline that these two calls happen sequentially. It's not parallel. First, like voter service call, then T-leaf service call. You can get these details from distributed tracing. But let's look into like why this is happening. So, if I open the first span, that can tell me that, hey, T-service, it received an HTTP GET request on this endpoint. I can see some details. I can see the error message. This was the same thing I saw in the logs. Also saying 404 in the error message, and the exception was not found. This was the exact URL. It was an HTTP GET on this host. It was a server error, 500. Okay, and this is the URL template. So what else I can see here? There is a very important indicator here. Do you see this red icon? That means bad. That means there was an error. So if I scroll down, I can see like another red icon on T-leaf service, which means that span also failed. So let's look into that. And in the attributes, what I can see that T-leaf service, it got this request from T-service. It was an HTTP GET on this endpoint, and this was resource not found. Resource not found English breakfast. And this was a 404 client error. So now I can tell that this whole 404-500 headache is because T-leaf service is returning 404 and T-service remapping that 404 to 500. I don't know who wrote that app, but I would be angry. So we still don't know why this is 404 there or why resource not found for English breakfast. But another thing I can see here on T-leaf service is a database connection and a database query. So if I look into the connection, let's see what is here. I can see that I am on this host, like the database on this host, and I am using the MySQL JDBC driver with Hickory CP, and this is the name of the database, which is nice information, but it doesn't help right now. Let's look into the query. So in the query, I can see, I am sorry, I did not write this query. This is Hibernate, but you can sort of figure out that this is a select query, and it is selecting a bunch of fields from the T-leaf table, where the name of the T-leaf is something, and that something is English breakfast. This is the parameter. So if you don't do this in production, or if you are very, very adventurous, you can SSH to this host, use this database, and run this select query. And you can see what the query returned. But I also happen to have like another span for the result set. And if I open that, let's see what is in there. Oh yeah, see this? JDBC row count equals 0. That means that this select query returned or resulted in an empty result set. It seems that somebody forgot to put English breakfast into the database. So let's put that back to the DB. I happen to have a script here which will just call the service and add that back. And while this is basically like, hopefully now this is fixed, let's check in the UI. It's good. So hopefully we will see that in the metrics, but while we are waiting for that, so that metrics will show up and we will see the change, let me show you another, or like two other things. One is, like, we just jumped from logs to traces using the trace ID. Nothing prevents you in a word that doing the jump the other way. So we have a trace here, which means that we know the trace ID. I can copy the trace ID, go back to my log ingestion system, write a query with that trace ID. And I teach like Tempo how to do that. So that I just need to press this button. And what I can see here is basically the query. Can I zoom in? Yeah. The query using that trace ID so that I can see all of the connected log events from all of the applications I have, which is a pretty nice thing to have if you want to, like, if you need like some additional details or want to see like all of the error messages or what basically happened in the app, you can do that. And you can see that if I scroll down, that this one, for example, from T-Leaf service, this is from, come on. So yeah, this was from T-Leaf service. This is also T-Leaf. This is T-service. This is voter service and so on. All of my applications, all of the connected logs are here. So you can do this pretty easily by this thing. And the feature is called basically like log correlation. So you can correlate logs to distributed tracing. And another thing I want to demo here is how to jump between traces and metrics. And one of the directions is much simpler or easier than the other one. Going from traces in metrics, that's kind of simple. Going to the other direction is harder. And this is because if you want to go from traces to metrics, the question that you are asking is basically, hey, I have this example span, which represents, let's say, like processing an HTTP request. Please show me all of the other events or show me an aggregate about all of the other events that are similar to this. And you basically just like get some metrics out of it. So what I can do, I can basically look into this span, for example, this one, and I have these tags or attributes or labels, different systems scores them differently. These are basically key values, metadata on this span. The observation API that is used to instrument these things, it is kind of enforcing you that both the spans and your time series, the metrics, they contain the same key values. The key is the same and the value is the same. So I can fabricate a query using these. I can just say, hey, show me, for example, an error rate where the HTTP URL was this. And I can copy it from here, where the method was get and the outcome was server error and the status was 500. All of the things that are similar to this, let's aggregate it. So I teach, like you can basically like do this like by hand. You can write like a shell script to do this, whatever. But I teach like Tempo how to do this. So basically what I can do is press that button and here is my query. And all of these things, application equals T-service, exception not found, status 500, URI, whatever, these are coming from this span. And this is called common tags. So I can use these common tags on the span and I can jump between these signals. And I just forgot to do something. So that's basically it. You can see that how to jump from like logs to traces using the trace ID. You can jump from trace to metrics using common tags. But how can you jump from metrics to traces? And that's the hard problem to tackle because there the question that basically you are asking is, let's say that you had like, I don't know, 1 million events or like 1 million HTTP requests coming in a time window. And what you are asking there is when you aggregate these 1 million events, and for example, you measure their latency, and you will get into one number, I don't know, max latency was 200 milliseconds of this 1 million event. How can you jump from that one single number, 200, back to one of these events? You have 1 million of them. Like that's a very, very hard problem to tackle because during aggregating these like events, into one single number, you are losing data. You don't know the individual events that happened. So exemplars are kind of for the rescue for this, because those are like example pieces of data. It's basically metadata, key value pairs that you can attach to your values of the metrics. So you are not just like when you measure the duration of something, an event, and you also report this or record this, you are also like going out to your distributed tracing library and sample a sample like span and trace, or you basically just store the span ID and the trace ID next to this. So you can basically jump from metrics, because while you are aggregating these things, you will have the trace ID and the span ID. You will drop some of them, but you will have some that the not the distributed tracing backend, sorry, the metrics backend will store. So let's look into the application again. Let's look into the metrics, and let's look into two things. One is I should have dashboards, yes. And let me do last 15 minutes maybe. Yes. So one thing that you can see here is that we fixed the issue. This was the throughput. What you can see above, that's the events, like the throughput for success events. And what you can see on the bottom, those are the errors. Interestingly or ironically, errors are the green one. Grafana should fix that. But what you can see here, once I fixed it, it basically went to 0. So that's good. But can you spot any other issues on these dashboards? This is latency. And this is not good. Like what you can see here, let me zoom in here, is that this is the maximum latency TP99 and TP95. And the max latency was around, I don't know, 30 milliseconds. Then something happened here. It started becoming wobbly. And now we are with the max latency 160 milliseconds. What is going on? This is pretty bad. Like from 30 to 160, that's a huge jump. So what I can do in order to figure out why this is happening is to jump from metrics to distributed tracing by utilizing exemplars. And what you can see on these dashboards, it is not just these three statistics on a graph, but you can see dots that are not connected. These are the exemplars. This is the sampled data. And if I hover over one of them, you can see that the trace ID is here. Also the span ID, this was like 120 milliseconds. This is the value of that sampled event. And basically all of the tags that the time series has. So what I can do, I can come here, pick one of them randomly, copy the trace ID, and I also come here where the application was slow, and say query this with tempo, split the view, and paste it here, and query this. So what I have right now, on the left, I have an example an example trace where the whole processing was fast, and on the right, I have an example where the whole thing was slow. So I can diff them together, and you can see that if I make this a little bit bigger, that this was the whole thing was 15 milliseconds. That's okay for me, for this application. Here, this was 120 milliseconds, more than 10x. That's super bad. So let's try to figure out why is this happening, or what this 120 milliseconds consists of. So first, let's look into what we have here when this is fast. So 15 milliseconds, the voter service call that was 6.5-ish, the TLEAF service call was 4. Okay, let's see on this side. Calling voter service was 111. That's definitely not 6.5, not even in the neighborhood. And this was 4.21, which is in the neighborhood of 4. That's fine. So the whole 120 milliseconds, we are losing that because we are losing 111 on the voter service call. And if I look into that, you can see that the voter service is basically calling the database. There is a DB connection here, 5 milliseconds, and 2 milliseconds like making the query, and also like 100 microseconds, 0.1 milliseconds for processing the results. That I don't care about that. So it's like 5.2-ish. Here, the database is 110. So voter service is slow because the database is slow. Right now, the database is not instrumented, so we don't know, we don't have a way to tell from this perspective if it is the database itself or if it is the network. But we can look into the database separately. So here, what happened is somebody, like these applications, they are not calling the database directly. They are calling the database to a thing called toxiproxy. And I used toxiproxy to inject latency on the network. So that's why this is slow. But let's continue with this, because there is one more thing on this slide to complete the circle, which is jumping between logs and metrics. And you can do that by stopping at tracing. So that's basically it. If you want to jump between these back and forth, you can jump between, because you can jump from logs to traces to metrics. And that's it. That completes our circle. We can jump between any of these, which is great. But let's say what if you want to implement these, for example, with Spring, or basically with any JVM applications. If you want to implement logging, we usually recommend using SLF4J with logback, and Spring Boot comes with these pre-configured. So SLF4J stands for Simple Logging Facade for Java, which is like it has a simple API that you can use for logging, or any libraries can use for logging, and you can basically plug logging libraries in and out. And logback is one of those, it's a native implementation of the SLF4J API, and you can use it, but if you don't want to use logback and you want to use like log4j2, it is basically in Spring Boot just replacing a dependency, and that's it. Boot supports both. It's pretty simple. If you want metrics, what we usually recommend is Micrometer. And Micrometer is a dimensional metrics library on the JVM. And we like to say that it's like SLF4J, but for metrics, which means that Micrometer has a nice API which is independent of the configured metrics backend or backends that you are using, because you can use multiple backends with Micrometer if you want to. And we have support for many of them. And Spring Boot Actuator brings you Micrometer, and it will auto-configure it for you. And Spring projects, the whole Spring portfolio, basically, it is instrumented using Micrometer. And there are many libraries, third-party libraries, outside of the Spring portfolio that are using Micrometer to instrument themselves. That list is shockingly long. But these are the supported metrics backends and formats, also like protocols that Micrometer supports. There are things here that are kind of like jokers, which means that one item here can support like many metrics backends. Like for example, StatsD, it's very widespread. The Prometheus format as well, or the Open Metrics format. So for example, like one thing, Prometheus, that doesn't only mean Prometheus. That means Prometheus and a bunch of other things that can support the Prometheus format, or like line protocol, or Open Metrics, if you will. If you want to implement tracing, distributed tracing with Spring on the JVM, we need to make a distinction here. Who is still using Boot 2? No one? Awesome, thank you. But if you would, then we would recommend using Spring Cloud Sleuth. That is the distributed tracing support for Boot 2 applications. But if you are using Boot 3, or you are not even using Spring, we are recommending Micrometer tracing. And Micrometer tracing is a library that was born from the code base of Sleuth. So basically, we just copied part of Sleuth, basically the API and some of the implementation, not the instrumentation, and copied over under the Micrometer umbrella. And that's how like Micrometer tracing was born. And because of this, both of them, they work very similarly. If you are familiar with the Sleuth API, the Micrometer tracing API is the same. The package name will be different, but that's it. Both of them, they provide an abstraction layer on top of their tracing libraries. So this is again this SLF4j situation. You have one API and you can plug like tracing libraries in and out. And we support two of them. One of them is called Brave from the OpenSapking community. And this is kind of like the default, except there is no default because you need to choose. And the other one is OpenTelemetry from CNCF. And this is kind of like experimental because OpenTelemetry is not 100% stable yet. So we usually recommend using like Brave by default. And Spring projects are instrumenting themselves using micrometer tracing. There are many third-party libraries that are using it. You can instrument your own application. And we have support for various backends, just because these two tracing libraries are supported by many, many backends. Good. Let's move on to this thing. I talked a little bit about it. It is called the Observation API. And maybe this is the most important part of this talk today, and maybe the most fun as well. But I will just I will talk a little bit about it, but I will talk a lot more on Wednesday. If you are interested in it, come to the Wednesday talk. But the problem that the Observation API is trying to resolve is that if you want to instrument your application, you might want to add some logs and instrument your components like that. And then you release it to production, then you will remember, oh wait, I need to add metrics as well. So you go back, modify the instrumentation again, and add metrics. Then you want distributed tracing. So you go back again, you modify the instrumentation again, and that's how we will have distributed tracing. If you want to add custom things to this, I don't know, writing audit events into an audit database, you need to modify the instrumentation again. This is a lot of work and even more boilerplate that you need to write because you need to start and stop timers, you need to start and stop spans, you need to do a bunch of things. So what we came up with the Observation API, which is not, it's kind of new in Micrometer, but it's not that new. It was released 1.5 years ago, in 2022 November with Spring Boot 3. What you can do is that instead of doing these boilerplating of starting and stopping timers, starting and stopping spans, you can start and stop observations, also signaling errors, and do attaching metadata and do other things as well. This is just scratching the surface. There are more things that the Observation API can do for you, but this is the gist of it. But what will happen if you do this? Believe it or not, by default, nothing. And this is because, if you ask me, the heart of the Observation API is a thing called Observation Handler. And the Observation Handler is a component in the Observation API. It's an interface that will be notified if you register it about these events. If you start an observation, guess what? The Observation API will be notified about it. If you signal an error or stop the observation, it will not be notified. So what you can do, you can implement, except a lot of cases you don't need to because we'll give you an implementation for these. But you could implement, if you don't like our implementation, a handler that will start and stop a timer when you start and stop an observation. You can have another handler that will start and stop a span if you start and stop an observation. You can implement your own custom logging things that basically will emit log events for certain events that happened in your application. You can also write certain events into an audit database handler from this observation data. So Spring Boot, it is auto-configuring handlers for you. So you will get, Micrometer will give you a default meter handler, which will create your metrics, and a default tracing handler, which will basically create your spans for you. So you will get instrumentation out of the box with the Observation API, and without touching that instrumentation, you can say, hey, I want metrics by just registering a handler for it. Hey, I want tracing by just registering a handler for it. Or I want a totally custom thing by just registering a handler for it. It is basically a bean. If you create an observation handler bean, Spring Boot will auto-configure it for you. It will register it, and it will be used and notified when these events are happening. Without touching the instrumentation, that's very important. You can get multiple benefits out of it like this. We also have like shortcuts because not everyone wants to always do this like try, catch, finally dance all the time. That's kind of like boilerplate. Here what you can see, hey, let's create an observation. Don't start it yet. Let me also add some like extra metadata, low coordinate key values, high coordinate key values, and let me observe it. And the parameter of the observe method, that's a method reference. That means that, hey, I want to please call this method, start the observation before it, call it, handle errors, signal those errors, and then at the end, finally stop it. If you look at the code, if you just like in your IDE, just hit the observe method and you like look into it, that's basically exactly the same what you saw before. And we also have like an annotation. You put that onto the method and that's it. And it will do the try, catch, finally dance for you and create an observation. And that's basically it. I wanted to tell you about the observation API for this talk. But let's also talk about what is kind of new in Micrometer. And new here means we released it in the past, like around 1 year. So one of them is improved exemplar support. So the exemplars thing I showed you, Prometheus did not support it for everything. You were not able to get it for a bunch of time series or type of time series. So we reached out to the Prometheus team and encouraged them to add it, also find the pull request, they merged it in and released it. So now you can get a bunch of more exemplars that you used to. And that support is also like Micrometer. After Prometheus release, like in like the next release, Micrometer had this capability as well. And this is pretty nice. And you did not notice it, but today we used it. Also, there is this thing, the meter provider. This is a new thing that you can use if you want to add like dynamic tags to your metrics. This is kind of like a shortcut or like kind of like some like syntactic sugar on top of the APIs. You can do everything without it, but this will make some things like a little bit easier and a little bit more performant. We also moved Micrometer to use the Prometheus Java Client 1.x because Prometheus, after 9 years, they released a 1.x stable version of the client. It was 0.x before for 9 years. So now Micrometer has it. If you are broken because of this, you can basically go back just by depending on like another dependency. Just look into the release notes or the we have a guide for it, how to migrate. It's pretty simple. We also have a doc site. Yeah, you can see that on the doc site as well. We do have a doc site. It's pretty new. It has like new search capabilities. You can check it out in micrometer.io. And also we have a bunch of observability improvements in the Spring portfolio, mostly for context propagation and auto instrumentation and for correlation. Spring Boot also issued like a new feature in the latest release for SBOM actuator endpoint. And the SBOM endpoint is basically lists all of your dependencies in an actuator endpoint. So you can ask your application that, hey, am I vulnerable for log4 shell? Am I using the wrong version of log4j2? Or like any other libraries or dependencies that you are using. And what is next in like Micrometer or like Spring Boot around observability? These were released in the latest milestones. So you can get exponential histograms for OTLP. This is just like another like histogram format. And also there is new validation capabilities for this thing called test observation registry that basically now validates your like usage of observation API. And if you are misusing it, it will let you know by throwing an exception. There is also process info contributor in Boot now, which is giving you like more information about the process that the JVM is running in. There is SSL info contributor and SSL health indicator, which is very new. It was just released like next week, merged in and released next week. What it does, it will give you runtime information about the certificates that you are using, client or server-side certificates. And it can tell you if the certificate is expired. It can also tell you if the certificate will expire within a threshold, then you define basically, so that it can basically say that, hey, this is this certificate and this will expire in the next 30 days. Do something. And you can re-rotate it before it will break you. Also, I'm not sure if you have seen the keynote, but Spring AI now is instrumented. And Mark will talk about that later in another talk. And with that, thank you very much. You can reach out to me online, and you can grab this project on GitHub. And also there is slack.micrometer.io, where you can also find the micrometer team.
Awesome.
Thank you very much.
All right. With that, we'll take a couple questions.
Yes,
Do we have any
and I
questions?
also have micrometer and Spring stickers, if you want.
Well, you did.
Do you want one?
I'll get one from you later. All right. Questions? Anyone? No questions? All right. Well, we'll let you go then. Thanks, Jonathan.
Thank you.
Appreciate it.